Okay, today is the first day of law of cosines. But I'm going to reiterate what the law of sines was. Let's say that you had a triangle that is not a right triangle. That is not supposed to be a right triangle. And let's say that this side here, it looks to me like it's about 40 degrees or so. And let's say that the side across from that was 8. Do you get that already this is setting up pretty well to be a law of sines question because we have an angle and a side across from it. What is the law of sines? Little a over sine big A, little b over sine big B, little c over sine big C. Now, which one's which? Do you know for sure what angle that has to be? Nope, it can be any. But just to get used to it, because on the law of cosines, this will matter, I'm going to call this C. Because if they give you an angle, you should call it C for the law of cosines. And since it doesn't matter for this problem, I'm going to call this one C. For A and B, just like in a right triangle, we really care a lot that this one's called the hypotenuse and that one's called C. And you don't really care if this one's A and this one's B or the other way around. It's just like that on a right triangle. On these triangles, we really don't care much which one you pick to be A and B. But I need one more number. Now, to me, these look longer than the 8, so I'm going to call this side right there 9. And I'd like you to figure out for me what is, if I'm going to call this one A, my choice, I'm going to call that one A. Find A using the law of sines. I'll pause for a minute while you give that a try. Okay, here we go. If we have A and C assigned, then obviously that leaves the other one to be B. So this guy must be B the way I've set it up. Did I have to set it up with those letters that way? No. But I recommend that the angle they give you, you call it C, because in the law of cosines, you're going to need to do that. Okay, so the A we didn't know, so I leave it as an A. Excuse me, this is talking that shouldn't be happening right now. Thank you. All right, on to the C. Oh, I know both of those. I'm going to start with that one then. So I'm going to put the C as 8, and the sine of C is sine of 40. With me so far? Okay, then this B here, do I know B? Oh, I do know B. B is 9. And then that leaves me with only one unknown. So basically, you can cross multiply and solve from here, and it's not too tough. What did you guys get for sine of B, and therefore what's B? You don't have it yet? I will call on you. Oh, what? 46.3. Can anybody verify 46.3? All right, good. So that makes this angle right here, that angle must be 46.3 degrees. Okay, cool. And if I know that one's 46.3 degrees, then this angle is really easy to find out because I know 2 out of the 3 angles. I take 90, I go 90 minus 46 minus 40, and what did you get for that last little angle? 93 point what? 93.7. Shows that I didn't draw it properly, but that's okay. All right. So then, last thought is I still haven't got A and sine A, but I could do part of it now. I now know that this is 93.7, and this is where A goes, and so therefore I now know this is 93.7 degrees, and I figured out B earlier, and B, which is this angle here, came out to 46.3, and now I know 3 out of the 4 of those things, and therefore I can figure out A. So I personally would have cross multiplied, and then once I had that, divided by sine of 46.3. Final answer, please. Let's see which person I should call on here. Row 6, group 1. That's you guys. What did you get? Haven't finished? Okay, I totally understand. How about you guys? Anybody verify 12.4? All right, good. Okay, so that's this side right here. Got to be 12.4. Okay, So that's a review of the law of sines. When is it good? When you have a side and the angle across. They're the ones that go together. A side and the angle across from that. So obviously law of cosines is good for when you don't have the angle across. So like for instance, let's say we set this one up. We say this is 7, and this one's a little longer, and it's 8. And the angle between them, actually, you know what, I'm going to do it this way. I'm going to make it a big angle. I'm going to say this is 7, and this is 8, and this is 120 degrees. Do you get, this is not a good setup for law of sines, but it is for the law of cosines. All right, so everybody draw that triangle. The law of cosines is really likes when you have a side angle sandwich. It's like these are the pieces of bread, and the angle that's in between is going to be sandwiched between them. Okay, so basically you want a couple sides and the angle in between them. That's what law of cosines is good for. All right, so ready? You guys have heard of a squared plus b squared equals c squared, right? But this isn't the right triangle. But if this had been a right triangle, just imagine for a moment, it would have been here, and this would be 8, and this would be a right triangle. Do you get that the side of over here, we would have called it C, that side is a lot longer in the black triangle than in the red triangle? Let's think that through. This side here is a lot longer in this triangle than it would be in that triangle, right? Because the angle opened up more. All right, so we have to make an adjustment. We can't just do a squared plus b squared equals c squared. So it starts with that, though. Everybody write down a squared plus b squared equals c squared is a right triangle formula. For a non-right triangle, you have to add in a little piece in here. There's extra stuff in there. And here's how it goes. A squared plus b squared minus, now we do know an angle. Did you notice that in the right triangle formula, you don't have anything about the angle? We do know an angle in this triangle, so we use it. A squared plus b squared minus 2ab cosine c is equal to c squared. It's the same formula with a little tweak. That part right there is the tweak, and it depends on how big the angle is. That'll make a difference on how long that side will be. C is going to be bigger if the angle's bigger than 90, and this is that factor that tweaks it. Okay, so now, do you get that if I just told you A and B, here's A, here's B, all I'd need is this angle, and I can figure out the answer because I got the whole left side of the equation. I just stick all the numbers in. So look at my picture. Do you remember me saying that in a law of cosines, the angle they give you should be a certain one? Which one should it be? C. This needs to be C. And if that angle is C, then the little side across from it is letter C. Do you remember me saying that the A and the B can alternate? It doesn't matter. They aren't picky. Okay? So I'm going to call this one A and this one B, but it won't matter if you'd reverse them. So A squared plus B squared minus 2ab cosine C now has become 7 squared, which is 49. I'm just going to write that right off the bat. Plus b squared is going to be what? 64. You should be writing right now, not just watching me. Minus 2 times a, which is 7, b, which is 8, cosine c, and he said c was 120, is equal to c squared. A really common tendency now, there's a whole bunch of junk to type in, and you get an answer, and you don't even think about it, and the answer is like 37. And you go, okay, so the answer is 37. Think about it. If you have one side is 7 and one side is 8, can the other side be 37? No. What are they forgetting at the end then? Square root, because you're finding c squared, So you need to take the square root at the end. Okay, so try to figure out what this one comes out to be. I will pause for a minute while you multiply that all out. All right, so here we go. I'm going to put these together, and these together make 100 and, oops, thank you, 113 minus, sometimes it is 56 times 2. 56 times 2 is 112 cosine 120 equals c squared. Now, I had some kids last hour, they were saying, why can't you just subtract 113 minus 112? It would be so much easier. You can't do that. This is multiplied by a variable, or in this case, another number. And in the order of operations, you have to do multiplies before you subtract. So I need to do 112 times cosine of 120. And then I got 113 minus that. I'm going to pause for a second while I find that number. Okay, and that one comes out to negative 56 equals c squared. And now I actually put it all together. What does this come out to? That doesn't make sense. Oh, you're saying that it was a negative 56 this way, and now I'm going to add them. Okay, good. Again, this part must have come out to negative 56. And now we have minus negative 56, which means you really add 56. 113 plus 56 is 169. And that makes sense because you guys are all saying it was 13. Squake the square root of both sides. 13 equals c. Cool. We know that side has to be 13. Okay, that's the law of cosines in action. Now I want you to go back and think about this just for a second. I got a lot of opinions on this last hour. What if I hadn't told you that it was 120, but I did tell you that the side was 13? In other words, let's say this was the given information. Do you think you would have been able to find the angle? And I think your gut feeling is probably yes, unless there's some kind of a sneaky, dastardly trick to it, and there's not. So yeah, you can do it. You can do it. So I know I could have made a whole new triangle so that you don't know what the answer is, but it's okay. We all know the answer for this is 120. My question is, can you please go back, and this will self-check, you'll be able to see if you did it right. See if when you put in all those numbers, I just erased the part of the formula I needed. See if when you put in the 7 and the 8 and the 13, that you can find angle C. Notice our formula is set up to find angle C. So we really can't find the other angles yet. All right, I'm going to pause while you guys stick those numbers into our big formula here. Okay, so this one, we have 100, I can't add that up again. 113 again, thank you, minus 56 times 2, 112, cosine C equals 169. Now I'm going to subtract the 113 from both sides. (56) negative 112 cosine C. Then I divide both sides by negative 112. Ooh, that works out really nice because cosine of C turns out to be negative a half. How do you solve that kind where you've got the ratio but not the angle? I got to get the cosine off of there. Inverse cosine. Inverse cosine on both sides. That cancels. Inverse cosine of negative a half. What's it come out to? Hopefully 120, just like we expected it to. Now, once C has been found to be 120 degrees, do you instantly know the other two? No, not so much. But law of sines would be way easier from here to find this angle, which we should call A because it's across from the little a here, right? So now we could use law of sines. A lot of your problems on the test will come down to you going, oh, I've got the side and the angle across from it. Law of sines. Or, oh, I've got two sides and an angle between it. I better use the law of cosines first. And then use the law of sines to finish it. So how could I use the law of sines to finish off and find that angle right there? I'm going to go sine, or actually a side first. So I know 13 over sine of 120, that's the law of sines in action here, goes with 7 over sine of A. And again, cross multiply and solve, and then you do inverse sine at the end, and you can get the answer that way. Okay. That is everything you need to know for today, except I need to do one last thing, and that's show you one of those ambiguous case problems and see if you can find the two ways you could draw the triangle. All right, so here's one of those. I don't know how long that is. I'm going to say that's 40 degrees. I'm going to say this is 7. Just start off and act like this is the easiest problem in the world. If it's a right triangle, then how long is the height right there of my triangle? I'm going to pause for a second while you use normal trig to solve that. All right, so you should have said sine of 40 is opposite, which is h, over hypotenuse, which is 7. How many of you set it up that way? Good, that's what I would have done. Then you would multiply both sides by 7, so it's 7 times sine of 40. If I remember right, this works out to a fairly decent number. What does it come out to? 4.5? All right. So height is 4.5. Okay, so now the height's 4.5. That would have been just too easy. So, 12 minutes left. So imagine for a moment that it isn't 4.5, because that wouldn't cause the ambiguous case. Let's imagine that this height is actually 5. So then, if it's 5, do you get I'm going to have to go either this way or the other way? We'll start by swinging to the right, and then later we'll swing it back to the left. But for now, just do it to the right, and that's 5. And figure out what this angle and this angle are, and you've got a side and the angle across from it. That's the law of sines setup. So use your law of sines. Figure out everything for this triangle. Then you have to be smart enough to know that this is an angle side-side. I warned you to watch out for these guys because they're a pain. So after you've got this angle and even this side along the bottom, those you could find easily from law of sines, then I'm going to ask you to put in this side and find out what the other triangle's dimensions were. Okay, so first find that triangle's dimensions. I'm going to pause for a moment. We'll use law of sines to find this guy's dimensions. I've got 5 over sine 40 in the law of sines. Would be equal to, I don't know what this is. I'm going to call it, I told you guys that this is probably good to call C. I'm going to call this A over here. Doesn't really matter what I call it. That angle would be 7 over sine A. Save me some time. Somebody's already solved this puppy. What's that angle in the lower right? 66? 64? All right. If that's 64, then I can use simple subtraction to find the top one. What is the top one? 76. Raise your hand if you had those the same as we did. Okay, good. Then the last side. Help me out. Save me some time. What's this last side come out to? One more time? 7.55. Okay, cool. So what does this whole ambiguous case thing mean? That means that that side, 5, could have just as easily, I'm going to clone this thing, swung the other way. And if it did, then it would have looked like this. And then the triangle would have been a lot smaller. Use the symmetry of this to say, okay, so this has got to also be 64, and this has got to be 5, and look at that. All these blue numbers I'm putting, they're all the same. They're all matching up so nice. All you need then is to figure out how long this is, and then you'll know that 7.5 minus this distance would give you that distance. All right, so basically just figure out that blue side of the triangle for me. Use law of sines to figure out the blue side of the triangle for me. Mr. R, you got it done yet? Okay. I'll help you. You're going to need an angle. This angle at the top. But it's not hard to get, because once I know the other two are 64, that adds up to 64, and 64 is 128. Take that off of 90, 52. That's 52 degrees up there. Then I can set up my law sines and go, this unknown blue distance, I'm going to call it B for the blue distance. All these you can call it blue. Over sine 52 is equal to 5 over sine 64. All right. All said and done, how long is the blue? 4.4. 4.4? Raise your hand if you had a 4.4. That's a lot of 4.4s. That's probably right. The blue, 4.4. So if that's 4.4, then the whole distance that used to be 7.55, now I subtract off the 4.4, and I can tell how long this distance is right here. That must be 7.55 minus 4.4, which is what? 3 point what? 18. That is the ambiguous case where you have to find both. Okay? I really think that honestly isn't going to be the toughest problem on the test. That isn't that bad. Because of all this symmetry running around, you pretty quickly realize that's the same as that. And if those two I already have, then you can find this angle really easy. And then if you know the law of sines at all, you can just find the other sides. Okay? All right. So now let's get into the homework for tonight. Everybody find the one called day 1 of this one. It's way at the bottom. Way. Page 25 currently. There we go. Right there, it's bright yellow. All right. I want to talk you through this. The first one, I've set it up for you. Remember me saying that if they give you an angle, you should call it C? That's really critical here. So as I drew those out, I decided instead of calling it gamma, which they had called it gamma, I called it C. And then the other numbers just kind of fell into place. This one's longer than this one is, so I went with the longer one. The one that looked longer, I called it 12, and the other one must be 7. That all make sense to you? They just gave you some sides and an angle. And once again, you got side, angle in between. That's the classic setup for law of cosines. Okay, so you use the law of cosines for this one. All right, for the next one, this is important. Do you get they gave you an alpha, which is like a big A, and they said big A was 104 degrees? What's wrong with that? We don't have a formula that has big A in it. Get what I'm saying? Our formula has A squared plus B squared minus 2AB what? Cosine of what? C. So we need angle C. So it's as simple as this. We say, well, I'm not going to call it A. I'm going to call that angle that they gave me C. But then I have to adjust for that. So this triangle can't work because it doesn't have any 100-degree angles in it. None of them are bigger than 90. So I'm going to redraw, and you should too, make an angle that looks bigger than 90 to you. We'll call it 104. I know, we're out of here soon. Not quite yet. So if that's 104, and we should call it C, do you get, they did not give you the side across from it. It's not 37. That's when they had them labeled as different things. We can't let them label it that way. So we didn't know the side across from the alpha because there's no little a equals whatever. So we don't know this, so what should we call it in our triangle? C. And we don't know it. Then the 25 and the 37 can just be slapped in wherever you feel appropriate. Which one looks longer to you? I feel like that one looks longer, so I'm going to say it's 37. And this one's 25. And notice I have a side angle sandwich. And those are perfect for doing cosine. Law of cosines. Go ahead, I understand. You have to go early. All right, so just notice I had to be really careful on how they set this up. Once you got it set up, the law of cosines is not hard to follow. And you can pick either A or B to be A or B. I don't care. I'll call this A, call the other one B, unless you really insist, in which case I can switch them and it won't matter. And then you use the law of cosines. Okay? So just because they said it was alpha doesn't mean you can't switch it and call it C. But then be careful. They did not give you A under their naming system. They didn't give you the side across from it. So, all right. I know, that's tricky, but that's what you got to be able to handle, is adjusting it so that C is the angle that they're giving you. All right, and the last two are kind of simple in that these are the only ones we're doing, is these four problems. So problem 7 and 8 here are the last two problems. And problem 7 is impossible. Tell me why. Just look at it. 1, 2, and 5? Can that work? There is no way you could make a triangle like that. So, boom, it's done. Now, had you gone through and actually done a bunch of stuff, you'd be getting answers that are like, this isn't working out. The angles are negative, or crazy stuff like that. So then you'd know, oh, I guess that's one of those impossible triangles. And then lastly is number 8. I have labeled it the way I wanted, but do you notice that it won't matter which one I pick for C? I can pick and solve for any of the angles, but whichever one I call C, that's the one I'm solving for. Get what I'm saying? I could, and some people have this misconception that C is always the biggest angle. It's not. C is just the angle that they gave you, or the angle you want to find. So if, and when I'm done finding this one, I can say, okay, now I'm going to call this one C and do my formula for that. But the one you want to find is got to be C, or your formula doesn't work. All right, only 4 problems for tonight, one of which was extraneous. So you got 3 questions. Get them done. That's all I got for you for tonight.